All right, so this problem has a 3 by 3 matrix. That means our system of differential equations had 3 equations, and it's got 3 unknown functions, okay? But we're gonna work it out the same way. We're gonna find the eigenvalues, we're gonna find eigenvectors for those eigenvalues, and we'll have 3 parts of our solution, okay? So the eigenvalues for this matrix are going to be easy. If you have a triangular matrix, your eigenvalues are just the diagonal entries. So we have eigenvalues 1, 2, and 3. So we'll just jump into finding the eigenvectors. So for the first one, lambda equals 1, we need to solve a minus ix equals 0. So that means I'm going to subtract 1 from the main diagonal and then augment that with 0 and solve for x. So 1 minus 1 would be 0. 2 minus 1 would be 1. 3 minus 1 would be 2. I'm just going to augment that with 0. Right. So let's row reduce this. This one's going to be fairly easy. If you ever get a column of zeros when you're row reducing, that column of zeros will never go away. So you can't get out of the zeros once it happens. I can divide the first row by 2 and the last row by 2, and I get 1 0 and 1 0 1 0 and 0 0 1. And then I can use this 1 to eliminate that 1, make that a 0. And then I can use this 1 to eliminate this 1, make it a 0. And now the others stay the same, and then I'll just move the third row to the second row. All right, so I'll get something like this. 0 1 0 0 0 0 1 0, and the last row is all zeros. So I've got 2 leading 1s here, and the first column does not have a leading 1. That means that's my free variable. So x1 is free, so I can let it be anything I want. For x2 and x3, these equations both tell me that they're equal to 0. So any vector that's constant 0 0 is going to be an eigenvector for lambda equals 1. So let's just pick 1 0 0. I'll just let x1 be 1. Okay, move on to the next one. For lambda 2 equals 2, I need to solve a minus 2i x equals 0. So I'm going to subtract 2 from the main diagonal instead of 1, and then augment that with the 0 vector and solve for x. So remember, this was 1. Let's just write it out. 1 minus 2. This was 2 minus 2. And then we have 3 minus 2 on the last one. And then augment with 0. So that gives me negative 1, 0, and 1. Again, this one's going to be easy to solve. So I'm going to multiply the first row by negative 1. You get that leading 1. I'm going to leave the second row alone. I'm going to use the second row to eliminate the 1 in the third row. So I'll just subtract those rows to get a row of zeros. So now I've got 2 leading 1s here and here. It looks like the second variable is free. So I will solve for all three variables here. So x1 would be 2x2, x2 is equal to 0, and x3 is free. I'm sorry, I did that wrong. x2 is free, and then x3, right here, x3 is equal to 0. So let's let x2 be 1, and I will get my second eigenvector, 2, 1, 0. Right, we got one more to do. So for lambda 3 equals 3, we need to solve this equation. A minus 3i x equals 0. So I'm going to subtract 3 from the main diagonal. So in the first entry, I can have 1 minus 3, so it's negative 2. And then the second row, I've got 2 minus 3, it's negative 1. Last row, I get all zeros. I get that 3 minus 3 there. So let's multiply the first row by negative 1/2. Multiply the second row by negative 1. So it's almost row reduced. I need to take this 1 and eliminate that 1. So what I need to do is take row 1 and subtract row 2. So I still have the row of zeros at the bottom. I'm not changing row 2. And row 1, I'm just going to subtract row 2. So I get 1 minus 0 is 1. 1 minus 1 is 0. And then 0 minus 1 would be negative 1 and 0. So I get two leading ones. The third variable is free. So it looks like x1 is equal to x3. x2 is negative x3. And x3 is itself. I think I made an error here. That should be negative 1 after we multiply by negative 1. So that's a negative 1. So this guy is going to be plus. Right, so they're all x3. That's kind of weird. So my eigenvector, if I let x3 be equal to 1, it's my third eigenvector. Just be all ones. All right. So now, so I have my 3 eigenvalues and my 3 eigenvectors. I'm going to write my solution. So I'll say vector x is c1 e to the 1t times the eigenvector for 1. So we found 1, 0, 0. And then second eigenvalue was 2. So I have c2 e to the 2t. And our eigenvector was 2, 1, 0. And then the third eigenvalue was 3. So I have c3 e to the 3t. And my eigenvector is the one we just found. It's 1, 1, 1. And that is your solution. Now you could write them all together into one vector, but it's okay to just leave it like this.